All right, let's talk about blockchain. It's a huge topic, right? But forget all the crazy code and confusing jargon for a minute. We're going to build one right here from the ground up. We'll use simple ideas to see how this thing actually works. So let's start with a really big question. Just think about it for a second. How many things in your life need a middleman? A bank, a credit card company, maybe even a government. But what if we didn't need them? What if we could connect and transact directly and just as securely? And that gets us right to the heart of it, the middleman problem. For, centuries, we've had to rely on these third parties to create trust. But that trust comes with a price. It costs us money, it causes delays, and if that one middleman goes down, the whole system breaks. To really get this, let's take a quick trip back in time to the music industry. Before the 2000s, right, the big record studios ran the whole show. They were the ultimate gatekeepers. Then, Napster came along. Suddenly, people were sharing music directly from their computer to yours, peer-to-peer. It completely upended the industry because it just cut out the middleman. Now, take that same idea and apply it to finance. Who's the biggest middleman of all? The financial industry, right? Banks are just middlemen for our money, which, let's be honest, is mostly just digital data anyway, ones and zeros sitting in their system. So the big question is, can we do for money what Napster did for music?
Well, okay, here's the catch. If you get rid of the central authority, if you get rid of the bank, you create this huge new problem. Who do you trust? How do you make sure the system has integrity when literally anyone can join in?
The challenge is a lot like herding cats. You've got this whole network of computers all over the world, run by people who don't know each other, and they definitely don't have a boss telling them what to do. So how in the world do you get them all to agree on a single version of the truth? It's tricky. So this is the million-dollar question, isn't it? How do you build a system you can trust when you have no idea who's using it, and you have to assume that at least some of them might be trying to cheat? And this lack of trust leads to one very specific, very dangerous problem, the double spending problem. You know, with a physical dollar, you can't give the same bill to two different people. But with digital money, what's to stop me from just copying and pasting my digital dollar and spending it over and over again? It's basically digital counterfeiting, and if you can't solve that, the whole system is worthless.
Okay, so we know the why. We want to get rid of the middleman. But to do that, we absolutely have to solve for trust. So, how do we actually build this thing? Let's do it piece by piece. Let's build our own secure digital ledger.
It really boils down to three main jobs we need our system to do. First, we need a solid way to document who owns what. Second, we have to protect that ownership so no one can mess with it. And third, we need to link the entire history of everything together so it can't be secretly changed. So step one, document ownership. Most banks just track your final balance, but our system is going to do something different. We're going to record every single transfer of ownership, every single one, as a transaction. You can think of it like a permanent public receipt. Who sent what, to whom, and exactly when. The full history of all these receipts is what proves who owns what right now. Okay, on to step two, protecting this stuff. Because if anybody could just write up a fake transaction receipt, the whole system would fall apart. We need a way to seal every transaction with a kind of unique, unforgeable fingerprint. But how do you do that with digital data?
The secret weapon here is something called a cryptographic hash function. And the best way to think about it is like a digital blender. You can throw anything you want into it. One word, an entire novel, all our transaction data. And it spits out a unique code. And that code is always the exact same length. That's its digital fingerprint. Now, this digital fingerprint has a few superpowers that make it perfect for the job. First, it's consistent. The same data will always give you the exact same fingerprint. Always. Second, it's a one-way street. You can't take the fingerprint and work backward to figure out what the original data was. And maybe most important of all, it is basically impossible for two different pieces of data to ever create the same fingerprint. It's the perfect, unforgeable digital seal. All right, so we've got our transactions and we've got our unbreakable digital seals. Now for the final step, the really clever bit, linking them all together to build the chain in our blockchain. So picture this. We take a bunch of recent transactions and we bundle them together into what we call a block. Our system then takes this block and creates that unique fingerprint for it.
For our first block, block 1, let's just say that fingerprint is 7F83B165. Pretty straightforward. But here is the stroke of genius. When we create the next block, block 2, we don't just put in the new transactions. We also include the fingerprint from block 1. Then we generate a new fingerprint for this whole combined block. So the fingerprint of block 2 now depends on everything inside of it and the fingerprint of the block that came before it. And that is why it's called a chain. See? If some hacker tries to go back and secretly change a transaction in block 1, the fingerprint for block 1 will completely change. And since that fingerprint is part of block 2, the fingerprint for block 2 will change too. And so will block 3's, and so on. The entire chain after that one tiny change just shatters. The tampering becomes instantly obvious to everyone. So let's just take a step back. What have we actually built here? We've designed a system where everyone can see the same history. And that history is basically set in stone. It's impossible to change without everybody noticing. We've managed to create trust without needing a trustee. You know, when you really boil it all down, this is the core mission. The whole point of blockchain technology isn't just about money. It's about finding a new way to guarantee that shared information is true and correct in a system where nobody is in charge. And that shared, transparent, unchangeable history, that is how you solve the double spending problem. Because everyone on the network can see the one true chain of events, no one can spend the same digital coin twice. It would mean rewriting history, and the chain makes that practically impossible. And that leaves us with one last really powerful thought. We saw how this kind of technology changed music forever. We're watching it change finance right now. So if blockchain is this fundamental new tool for creating trust, what's next? Supply chains? Voting? Real estate? What other giant middlemen could be on their way out? That's the real question this technology forces us all to ask.